Hi there, welcome to the trial test class. We're looking at test paper number 1 today. If you can turn to test paper number 1, let's start with question number 3. Okay, question 3 says, a timekeeper's stopwatch loses 1 second per minute. After 2 hours, what will the stopwatch read? Okay, so this is question 3. So what we got is, it loses 1 second for every 1 minute. Now, after 2 hours, so we're looking at 2 hours, that equals to 2 times 60 minutes per hour. That's going to give us 120 minutes. Now, we know from here, it loses 1 second per 1 minute. So therefore, the stopwatch is going to lose 120 minutes times 1 second, which will be 120 seconds. Now, 120 seconds, as you know, we divide it by 60 minutes, that will be 2 minutes. So therefore, the stopwatch will be reading 120 minutes minus 2 minutes. That would give us 118 minutes. Now that answer in this case is going to be B. Okay, so remember to calculate how many minutes it will lose actually, then subtract it from the real time 120 minutes. So the answer is B. Now let's move on to the next one. Let's have a look at question 8. Now have a look at the diagram that's been provided by question 8. The first 2 sets of scales are balanced. We want to find the number of circles needed to balance the third scale. Let's have a look at the first 2. So this is question 8. Now let's go through each one of these scales. Now question 8 from the first scale. Now we got 3 squares were equals to 2 circles. Now so therefore from this we can formulate that 1 circle were equals to 3 squared divided by 2. We divided both sides by 2. Now let's have a look at the second diagram, or the second scale. Now we've got 3 circles equals to 1 hexagon. Now, so 3 circles, as we know, are 3.5 squares. So therefore, instead of circles, we substitute in 3.5 squares. So that's 3 times 3 squared over 2. So that's going to be 3 times 3 give us 9. So 9 over 2 squares were equal to 1 hexagon. Now with the third diagram, or the third scale, what we have is we want to find what are 2 hexagons equals to in terms of squares. So therefore, 2 hexagons were equals to, that would be 2 times that, 9 squared over 2. So the 2 will cancel each other out, and we're going to have 9 squares. So 2 hexagons will be equivalent to 9 squares. So that answer in this case, this will be A. Okay, so A for question 8. Let's have a look at question 26, a few pages down. Question 26. Now, have a look at the equation that's been provided in question 26. Now, we've got a number of brackets here. Let's rewrite the question. So, question 26. So, I've got 4A minus, big bracket, 2A minus B plus another bracket, A minus 2A plus B, close brackets, and close the bigger bracket. Now, this type of equations, if you remember from your order of BODMAS, now you want to make sure that you follow the order operations. whatever is inside the inner bracket first, you need to work on that one first. So in this case, we want to be looking at 2a plus b. So we want to expand that with a minus at the front. So we can think of it like there's a 1 at the front. So what we want to do is expand that bracket. So we still got 4a minus 2a minus b plus another bracket. So a minus 1 times 2a will be minus 2a. Minus 1 times plus b is minus b. And then close it with a big bracket. Now we need to simplify what's inside this bracket here. So that will be 4a minus 2a minus b plus a minus 2a is minus a minus b, and close with a bracket. So we need to get rid of that. Now with the plus sign in front, now because that's being a plus, that's not going to make any difference to these two signs here. So that will virtually still be a minus a, and that's still a minus b. We can simplify these four terms. So that will give us 4a minus, now 2a minus a is going to give us a, minus b is going to give us minus 2b, and close that bracket. So that big bracket has been simplified to a minus 2b. Now we've got to be careful here. We've got a minus at the front, so that's like a minus 1. We need to expand that, taking the sign into account. So that will become 4a, minus 1 times a becomes minus a minus 1 times a minus 2b becomes a plus 2b. Now we can do the final simplifying. So 4a minus a gives us 3a, and 2b, there's no other like terms, so that will remain as 2b. So therefore, in this case for 26, our answer is going to be E. So with this type of operations, make sure you follow the order correctly, okay, in simplifying, and work it from an inner bracket first, then work it out eventually. Let's have a look at question 27, which is right next to it. Now let's read through the questions. Iris was absent in an exam because of a fever, and she had to take her exam a few days late. She scored 96 on her exam, which is found to raise the class average on the test from 81 to 82. How many students took the test altogether? So altogether means including Iris as well. So let's look through that. Question 27. Now, as you read through the question again, let's record down some details. 27. Okay, so the average originally was 81. So let's say x equals the number of students that's sat for the exam. This is excluding Iris. Okay, so before Iris sat for the exam, the average is 81. So we got x number of students. So this is the sum of their score divided by x number of students, and the average is 81. So we multiply both sides by x. So the sum of the score original is 81 times x, which is 81x. Okay. Now Iris sat for the exam. She scored 96 on her exam. So we add that total, 81x plus Iris score, which is 96. Now we want to find the average. So that's going to be x plus 1. So that's the number of students before Iris. So you need to divide by x plus 1. That's including Iris in here. Now the average has improved to 82. We want to get rid of x plus 1. So we multiply both sides by x plus 1. So that's going to be 81x plus 96 equals to 82 times x plus 1. We want to expand that bracket. So that's going to be 82 times x is 82x. 82 times 1 is 82. So that's 81x plus 96. Now we bring all the like terms together. So 81x would go onto this side, and 82 would go to the left-hand side. The sign would change from a plus to a negative when you take it to the other side. And similarly for plus 82, that would become a minus 82. So that's going to be 96 minus 82 equals to, we've got 82x minus 81x. Now 82x minus 81x would give us 1x. 96 minus 82 is 14. Now x is the number of students that took the exam before Iris. So we got 14, but the question says how many students took the exam altogether. So that's going to be 14 plus 1. So our answer in fact will be 15. So 14 plus 1. So in this case, that's going to be D. Now let's have a look at 44. Turn over a couple of pages for me. 44. So it says, a circular sheet of paper is cut into quarters. The quarter paper is then folded into half along its axis of symmetry and then half again. It is then folded into half for the last time in the same manner. What is the size of the angle between the two straight lines of this newly obtained shape? Let's list down the information that's been provided. So question 44. So initially, a circular sheet paper is cut into quarters. So we start with one piece of paper that cuts into quarter. So that's a quarter of the original size. Now the quarter paper is then folded into half along its axis. So you think of it this way. This is my quarter. That's folded into half. Okay? So you turn into a half. So you divide by 2. It's like multiplying by 1 on 2. And then half again. So half again. And then it is folded into half for the last time. Half, so you multiply by half again. So we multiply that out. That's going to be 1. 4 times 2 is 8. 2 is 16. 2 is 32. Okay, let's double check. 4 8 is 32. So it's 1/32 of its original size. So we want to find the angle between the two straight lines. Now originally that's 360 degrees. So you divide by a quarter, or it's multiplied by 1 on 32, so you divide by 32, or multiply by 1 over 32. So 360 divided by 32, that's going to give us 11.25 degrees. Okay, so roughly 360, 36 and 32, that's slightly more than 10. So that's going to be 11.25 degrees, and that's the answer is going to be C. Okay, so just follow through the questions and list down the information as you go along. Now, I trust you find these examples pretty useful as you tackle the rest of the problem, and enjoy while you're doing it. Bye for now.